Right, so let's continue with the week 4's topic, which is accuracy and precision. So you would have looked at the video before with William Tell and the crossbow. So let's kind of get a little better idea of what accuracy and precision is. Now, very often, a lot of people tend to use the word accuracy and precision interchangeably, as though they mean the same thing. That's actually not true at all. Accuracy and precision are actually two completely different things. So let's start with accuracy. Accuracy is basically how close your experimental values come to the actual value that you're trying to measure. So let me bring that into some perspective. Let's just say we are looking at finding the value for gravity. Gravity at the CSEC level is taken as 10 meters per second squared or 10 newtons per kilogram, unless otherwise stated. And so let's say you're doing that experiment and you do the experiment twice. The first time you do the experiment, you get a value of 15, which is 50% more than what the actual value is. So that's very, very inaccurate, way off from what the actual value, which is 10. So your experimental value is 15, your actual value is 10. If, however, on the second time you get 10.01, right, you're just a 0.01, that's 100th of a meter per second squared of the actual value. And that's pretty accurate. That's very close to what the actual value is, 10. So we could say that 10.01 is a more accurate value than 15, right? So if we have to define this, we would say that accuracy is, of course, how close your experimental values are to what the actual value is, right? On the other hand, precision is, well, basically a property of the instrument to be used. So some instruments are more precise than others, right? So to understand this, let's really kind of take a look at maybe the simplest piece of instrument that you have, which is your ruler. Your ruler measures, the smallest measurement on your ruler is 1 millimeter. So let's just say you're doing a measurement and the measurement is falls between 10.1 cm and 10.2 cm, right? So if that measurement falls in between that 0.1 and 0.2 cm there, between that 10.1 millimeter, 10 cm 1 millimeter and 10 cm 2 millimeters, right? You basically now have to estimate how much that is. Now the best you can do at that stage is say, well, it falls between 10.1 cm and 10.2 cm, so that's 10.15. But it could be 10.14. It could even be 10.13, right? But you can't be certain, because you certainly can't look at that 1 millimeter marking and break it up into 10 pieces and say, yeah, well, that looks like 10.11. That's not possible, right? So at that point, you are uncertain, right? You have some level of uncertainty. So the uncertainty of this instrument is when it has, the ruler in this case, has a measurement that's less than 1 millimeter. So the uncertainty is 1 millimeter, but less than 1 millimeter, right? Now, if we use a more precise measuring instrument to measure length, let's say a vernier caliper. The vernier caliper, for example, measures up to 1/10 of a millimeter. So you can actually, if you're measuring whatever you were measuring before with the ruler, if you take the vernier caliper, you could actually state whether this is 10.14 or 10.15, right? So it measures up to 1/10 of a millimeter, right? And so therefore your uncertainty at this stage, if you had, let's say it falls between 10.11 and 10.12, which is less than 1/10 of a millimeter in this case, you're uncertain up to less than 1/10 of a millimeter, right? So, and then if you want to go even further to an instrument that is even more precise in measuring length, we could use maybe something called a micrometer screw gauge, right, which measures less than 1/10 of a millimeter. In fact, it can measure the diameter of one strand of your hair. So what we're noticing so far is that precision, right, hinges on well, the smallest value that the instrument can measure. The smaller the value the instrument can measure, or the smallest value that the instrument can measure, makes that instrument more precise. So the ruler, 1 millimeter, the vernier, which is 1/10 of a millimeter, is more precise, and the vernier, which I think is up to 1/100 of a millimeter, that's even more precise, right? So less room for approximation, right? Now, of course, if you're using a more precise instrument, right, the chances of you getting a more accurate measurement becomes higher, right? Because the instrument that you're using, if it's more precise, you have less approximation, and therefore you run the chance of getting a more accurate measurement, right? So if you had to define precision, it would be the precision of an instrument is a measurement of the uncertainty of the instrument. All right, so you can be precise by using a very, very precise instrument, but you can measure it, wrong, inaccurately. So you can be precise and inaccurate. You can also be accurate, but not precise. So that would have been just a little bit of luck there if you're measuring, right? So it's possible, right, to get more accurate measurements using more precise instruments. And precision, of course, is simply a property of the instrument. More precise instruments mean that they measure smaller and smaller amounts, right? So that's basically what accuracy and precision would look like. In the next video, I will use two balances, two scales, and you can hopefully get a better picture of what accuracy and precision will look like there. And please make sure and do the assessment at the end. I also have a little bit of a summary prepared. So read the summary, go through the couple of questions, and that's it for today. So I'll see you in week 5.